Hey there, Agile Sugar, Agile Spice, Agile Everything Nice, and welcome to another episode of Agile Bytes, the podcast sponsored by Integrity Inspired Solutions, where we're building software in an agile manner day in and day out. Today, I want to talk to you about test-driven development. It's a little bit more of a technical topic, but as I've mentioned before, there's a strong technological aspect to being agile, and you ignore it at your peril. In fact, it could be arguable that the technical aspects of agility may even be more important and have more of an impact than some of the other aspects of agility that we talk about. They're definitely necessary to enable high levels of agility for sure. There's many components to the technical side of agility, and today we're going to be talking about one of them, one potential area, which is test-driven development. Now, if you're not a developer, you might be thinking, well, perhaps this episode isn't for me. Well, the good news is we're not going to dig really deeply into the technical ins and outs of how TDD works. I want to tell you what the concept is so that you can be conversant with it with your own teams and maybe begin to have conversations with your developers, or if you are a developer, have a conversation within your own team about whether this practice is right for you and how you might adopt it and what it might look like. But what I really want to do is make sure you understand that TDD is not simply a technical practice. It also relates to our agility, definitely falls under the Agile Manifesto banner of better ways of developing software. I also want to say as we get into this that I do teach developer teams how to do TDD. It's a one-day workshop that is easily subdividable into 4 2-hour chunks. So if this is interesting for you, or your team is very interested in TDD but doesn't necessarily know how to get started and they would like to see someone do it, I am happy to do that with your team. Just reach out to me. So I want to talk first about TDD as an overall strategy. TDD is a specific programming practice, and I will get into that. That's what it actually means as it refers to this specific practice. But I have found over the years that the principles and spirit and philosophy behind TDD has much broader applications than just test driving out code. The idea behind TDD as a strategy is you write the test before you create the things that fulfill that test or accomplish that test. You define the test first. And this is in opposition to the way most of us are used to dealing with testing in tech, which is you create the tech first and then you test it. So TDD is that we construct the tests first and then we create what we need to create to make those tests pass. So an example that I bring up is actually the American public school system. So when I was in 4th grade, we had to memorize the names of all the states in the United States, as well as the state capitals. Here is what my teacher did not do. She did not ask us all to write what we thought the names of the states and the capitals ought to be, and then create tests around what we had done. That would have been cool, because then all of us would have gotten 100% on our tests and we would all have gotten A pluses. But it turns out that she didn't want to write tests around what we produced. She wanted us to produce responses in line with a test that she had created beforehand. So what she had done is she created a test where we had to list out 50 states, and next to those 50 states, we had to write those capitals, and she had an answer key that had all the right answers. So the test was already built, and now we had to learn and produce a response that lined up with what the test was expecting. And it was on the basis of that we were graded. So we're all probably used to environments where everything is focused on fulfilling some kind of success criteria that has been defined before we got there, right? And test-driven development is really taking that same basic idea and then applying it to our software production, right? We are going to create the goals, create the test first, and then act in a way to fulfill what has been created. The problem with writing the test afterwards is we are just confirming what we did. It's sort of like shooting an arrow and then painting a target around it, or having somebody write what they think the 50 states and capitals are and then creating the answer key around what they wrote. we're confirming what you did, but we're not establishing whether it was the right thing. And so what we want to do is define the right thing up front, and then we can orient all of our activity toward hitting that target, to doing the right thing. And this is a philosophy we can apply to lots of things in our software development work, not just the code. When we define the test beforehand, it makes the goal very clear, right? The test defines what right looks like. It defines what our target state is, our goal is. It documents what we understand the right outcome to be, right? When I look at a test or I look at a written goal or a written standard, then I know at that time what our understanding of correct is. And if I disagree or have a different idea, we can have a conversation about that, because the test documents what we think the right thing is. And through that mechanism, we can come to a shared understanding through discussion. Also, by having that defined up front, it creates very economic and focused action. When I knew the test was about the United States and the capitals of those states, what I didn't do is spend time memorizing the chief exports of each state, or the populations of each state, or the accents of people from each state. I didn't spend any time learning that stuff because that was not relevant to passing the test, right? The test helped me focus on what I needed to do and where I needed to spend my time, because hitting that target was the goal. I didn't have to drift off into all these other things. That might have been cool information, perhaps even useful information. It just wasn't of immediate concern because I had a test to pass, right? So we can apply TDD as a larger principle, as a larger strategy to all kinds of things. For example, have you ever been to a meeting without an agenda? Are you scared of meetings without an agenda? I sure am, because when I go to a meeting, I want to know what the outcome of that meeting is supposed to be. Is it a specific deliverable? Is it a specific decision? Is it to share and discuss a specific piece of information? I want to know what the outcome of that meeting is before I go there. Why? Because then I can structure the meeting to focus on hitting that thing. I'm not going to talk about 50 other things that are not relevant to the agenda, right? Because I'm focused on that target. We might even think about the different events in Scrum, for example. If you know what the target is, then you can make sure that the event is shaped around that target, right? So if I think the target of the daily Scrum, for instance, is to inspect our progress toward the sprint goal and then make our plans as a team accordingly, then I'm going to orient the event around getting those things done. If I don't have that target, maybe I have no target, then I'm probably going to go around the room and have everybody say what they did yesterday, what are they going to do today, and if anyone has any roadblocks, right? So the target shapes the focus. We can apply the basic philosophy behind TDD to things like our marketing experiments, right? What are the outcomes? How will we know that this experiment was a success? We can orient it around our product increments. As we get product increments out the door, how do we know that this product increment is a success? Let's define that up front. Let's not wait and see what happens and then define success around what happened. Let's figure out what success looks like before we get started. Many OKRs in companies revolve around this principle. And then, of course, we can apply this principle to code, which is where the practices of TDD actually came from and what they are primarily concerned with. But I did want to talk about it as an overall strategy because I do believe that the principles behind TDD are just good principles for most business endeavors, right? Define what success looks like for whatever it is, and then orient everything in that activity around that definition. Okay, we are going to hit the target and we're focused on that target as opposed to 8 million other things we could be doing. So now I want to talk about TDD as an actual practice, the way the practice was meant to be. Now, I will say that this practice, like many other practices, people are not always on exactly the same page as to what exactly this is. They may have read different things or come up in different schools of thought. So it's entirely possible that my accounting of this may be different than what you think TDD is or what TDD ought to be, and that's fine. I'm not right about everything. Hope that's not a hot take. Hope that's not a news flash. So If my definition doesn't sound like what you're used to, that's totally fine. You are welcome to adopt the definition that works for you. I'm going to try to explain my thinking as I go. So even if you disagree with me about whether or not this is, true TDD or whatever, at least you'll understand where I'm coming from. So in coding, there are basically two very large categories of tests. Now, there are tons of types of tests, right? Smoke tests, A/B tests, there's recovery tests, there's all kinds of tests. And I'm going to sort of lump them all under two large categories. One of these categories is integration. In other words, I'm testing multiple parts of an application that are working together. Now, that doesn't necessarily mean it's an end-to-end test. An end-to-end test is a type of integration test where I'm starting at, say the web page, I'm starting at the screen and the operations drill all the way down to the back end and then come all the way back up. I may be hitting an API endpoint to see if the JSON that comes back is what I expect. That is another example of an integration test. I'm just testing multiple pieces working together to see if the outcome is what I expect or not. The other big category that I'm going to talk about are unit tests. Unit tests are when we test a behavior of code of the application in isolation from all of its dependencies. So let's say, for example, I'm writing the code for a command handler to edit a customer's information. So new customer information is coming in. I'm probably going to hit a customer repository, ask for a customer. I'm going to get that domain object. I'm going to mutate its state according to the new data that has come in and give it back to the customer repository to save those changes back to the database. So there's a lot of moving parts in what I just said, and there's some dependencies, right? I'm using repositories. The repositories are using the database. If I'm wanting to unit test this command handler, then I'm wanting to test its behavior in isolation from the other things in code that it has a dependency on in order for what would normally be an integration test to work, right? When I am unit testing a command handler, I don't want it to save anything to the database necessarily. I may not want it to call a real repository. I might want it to call a test double version of the repository, because what I really want to test is the command handler. I want to make sure the command handler is doing its job right. I'll worry about other units of code doing their job right at other times if that's valuable to me. So those are the two basic categories. Integration, where we are testing several behaviors of code working together to make sure they do the right thing. And unit tests, where we are testing a single behavior of code, usually in isolation from its other dependencies and other behaviors of the code. So again, you may have issues with that division. You may have another division that works well. You might be thinking, well, that's not what an integration test is to me. I understand that, but that's how I'm using those two categories. The reason that I bring this up is because when we talk about test-driven development, both kinds of tests end up getting involved, even though the bulk of it is usually around unit testing. Now, what I'm going to lay out for you is a scheme that is relatively old in software development, and we have a lot more options now. So this scheme has kind of evolved. There are more variations to it, especially as client-side frameworks have become more advanced. Now we can write unit tests against the client side, which used to be difficult, if not impossible, several years ago. We can, isolate the client side and have a very fully functional, rich client side with state management, options that we didn't have, say, 15, 20 years ago, the way we do today. So this scheme is a little bit different, but here's basically how it goes. The first thing you do is you write an integration test around the entry point into a business capability, which is kind of a fancy way of saying you write a test around what it would mean for a user to do something, right? So let's take logging in. Okay, we're all familiar with logging in, right? So if we were going to build a feature for our application where people could log in, I would start by writing an integration test around logging in, probably based on the login screen. So that test might look something like, if I want to log in, then I'm going to put my username into the username box. I'm going to put my password into the password box. I'm going to click a submit button. And if I gave the right credentials, then I should be taken to the home page of the app. that would be an example of an integration test for that business capability. Typically, we would write this sort of test first, although it would be the last thing to fully pass in a full, complete way. Again, the client-side technologies have evolved to where this may not be exactly the path we take through these things, but nevertheless, we usually start with the integration point, mostly because for the user, the screen is the capability, right? They have no idea what's going on under the screen. So that's the thing we want to get right first. And it's the thing we want to make sure is solid before we leave it, right? Then what we would do is we would say, okay, well, I can create a UI and I can create text boxes and buttons, but they can't work unless I write code in the middle tier, right? And they can't work unless I'm, doing data storage and things like that. So then I go a layer down, right? Well, when they fill this out and click this button, what happens? Well, maybe it calls an API endpoint, and that API endpoint is maybe my entry point into the business logic. Or maybe it really isn't. Maybe my API endpoint is something that is very, very, very thin, but it calls a command handler, and that is my entry point into this business logic. So whatever that entry point is from the next layer of code, then I would write a test around it. What are these objects going to be called? What are these methods going to be called? What am I going to feed them? And what do I expect them to return? I'm defining all of this in the test. Now, these things don't exist yet, right? So this test is going to be read. It's probably not even going to build, most likely, right? But as I'm writing the test, I'm creating what I think this flow is going to look like, and what parameters is the code going to take, and what am I going to call these things? What am I going to name these methods? Who's going to have what responsibility? I'm sort of driving all these out by creating a test to test this code that doesn't exist yet. Then I write the shortest, smallest, simplest amount of code that I can to make that test pass. Okay? So I maybe create these classes that the test references. I create these methods. And a lot of times the shortest, simplest way to get the test to pass is just to hard code a response that matches what the test is looking for. And eventually, as I do this, the test will turn green. In other words, it will pass. It will build and it will pass. And now I know I have a stable point for refactoring. And now I can start fleshing out this code. Now I can start, calling repositories and doing whatever I'm going to do, knowing that as I refactor that code, I have a stable point. So as I begin to change code, that test is going to quit passing. And so I need to write the code that makes the test green again. So I'm always writing the code that advances behavior, but I'm always refactoring to make sure that my tests stay green. And I just repeat this process over and over for each piece of code that I write most of the time. I will say that there's some code that I don't test drive out because it's trivial, but generally speaking, we're driving out our code this way. And then eventually all the layers will be built out. The integration test at the very beginning is going to be fully passing. And then I know that we are done. We have met our functional criteria. We've met any acceptance criteria we've got to worry about. Our tests are all covering those things and we look good and we're done. Now, again, this isn't exactly the path you take through everything, but it at least sort of gives you an idea that this is the way TDD works. Write the test, write the code that makes the test pass, and as you refactor and integrate more and more of the code, you have a stable body of tests that will break, and then you can refactor your code to make those tests green again. When everything's green, then you are probably done, right? And so this doesn't mean that we write all our tests up front and then start coding, right? Most of the time, TDD is you write one test and then you write the code to fulfill that test. Nor does it mean that your tests can't change in light of what you learn, right? Like I may write a test first, but as I start writing the code, I start getting new ideas or think of a better way to do it. I may have to go back and revise my test based on what I've learned or the new idea that I've had. So TDD does not mean writing every possible test before you write code, nor does it mean that the tests can't be changed in light of new information or better ideas. It just means that we write the test first, and then we write the code that satisfies those tests. We create the goal, and then we write the code to meet that goal. So why do you care? Why should a team who cares about agility care about a technical practice like this? Well, One thing is that when we adopt TDD, especially if we adopt this strategy more holistically, is it gets the activity of testing and testers involved right at the beginning, right? Our tests and our testers have to understand right at the beginning, how is this feature supposed to behave? How is this capability supposed to work? And we can start doing work on our tests right from the get-go. If you have a QA person who operates off test scripts, they can write that test script as soon as we pull that user story. There's no reason they can't, right? Even though the screen may not exist yet, even though it might not be coded yet, they can still figure out what's the sequence of events, what are the UI elements that are going to need to happen, and then we can start creating those integration level tests. So it gets everybody to the table from the very beginning. Testing becomes a continuous activity through the production of a feature that we're all aware of the entire time. TDD also means we do less rework, right? Because we are coding to those tests. We know the tests pass by the time we're ready to release. So the odds are pretty low that we're going to need to fix bugs in production. So we don't waste that time for rework. We don't throw a bunch of bugs over to QA or find a bunch of bugs in production. TDD means that the risk of change is lowered. Again, if I have a suite of passing unit tests and the requirements change, well, now I know right away if making that change is going to break anything, and I can do what I can to make sure my tests all go green again before I introduce that change back into trunk or back into production or something like that. So we can make changes boldly and more frequently, knowing that the risk of breaking things is very, very low. TDD lowers the ramp-up time for new developers because it serves as documentation for our system's behavior, both at the macro level and at the micro unit level. TDD means we spend less time writing code. We have less code because the code that we write is focused on making the test pass, not all the little boilerplate or gold plating and weird edge cases and things like that as developers we like to concoct and code for. The tests focus our development effort. I would say since I got into TDD, I probably write about a third less code than I used to. Less code means less risk as well as less time. TDD also meshes with other technological practices that enable agility, like continuous deployment or trunk-based development. You don't have to do those things to do TDD, but TDD meshes very well with them. And you get practices like this involved in your production, and you will find that technically you are very agile. You can make changes very quickly. You can deploy changes very quickly. You can deliver value very often, very quickly. And then finally, TDD aligns all of our activities around a common understanding of behaviors. You know, a big thing that is a hitch for a lot of teams, especially for large organizations, is the people gathering the requirements, the people coding the feature, and the people testing the feature are three different groups of people. And when this is the case, sometimes you can have three very different understandings of how this feature is supposed to behave and what's important and what isn't. Some of the people doing this work may not have even been present for the conversations about what these features mean. But when you are doing testing up front at the integration and at the unit level, now you have a common basis of understanding. Everybody knows this is what it means for this feature to work. It aligns all of our activities around a common understanding of behaviors. So if QA is finding defects, it's some freaky thing that nobody thought of, right? And it's not a list of defects that come from the fact that the developers thought it should work one way, but QA thought it should work a different way. Or the customer had one thing in their heads, but the developers had a very different thing in their heads. So you should care, as people who care about being agile, about TDD, because ultimately it lowers a lot of wasted time, lowers a lot of risk of change, it raises quality, and perhaps the holy grail that we're all looking for, it unites everyone in our team around a common understanding of what success for the customer actually looks like. Thanks everyone for listening to Agile Bites. Agile does sometimes bite, but we don't think it always has to. If you enjoyed what you heard today, don't forget to like and subscribe to this podcast on whatever platform you happen to be using. And if you can, leave us a comment because we'd love to hear your feedback. What things would you like to hear about? What things did you hear that were valuable to you today? You can also head over to integrityinspired.com to sign up to our email list. But that's all for today, folks. We'll see you next time.